Start strong. Modern AI models are exceptionally fast. They can turn out massive amounts of code and text in seconds. But in a professional setting, speed without independent judgment is a liability. When faced with a complex bug, most models blindly rush to patch the surface symptom, leaving the actual source of the problem untouched. To get true autonomous behavior, an AI capable of navigating complex, multi-step workflows, you had to pay a steep premium. You were forced to route your tasks through massive, highly expensive frontier models like Fable 5, which slowed down execution and drove up computing costs. Anthropic's release of Claude Opus 5 breaks that long-standing economic compromise. It delivers near-frontier, agentic intelligence at the baseline price of previous generations. Look at this chart plotting cost against autonomous capability. Legacy models sit down here in the bottom left, while flagship models like Fable 5 sit way up in the top right. Opus 5 lands completely outside that established trendline. It maintains a massive 1 million token context window and approaches Fable 5's intelligence peak, but operates at just $5 per million input tokens, matching the exact cost of Opus 4.8. By making highly capable, autonomous problem-solving this cheap, Anthropic has turned what used to be a premium luxury into an everyday default. We can see this autonomy in action on benchmarking environments like OS World 2.0, which tests how well an AI handles novel computer use tasks. Opus 5 dominates these tests because of how it reacts to roadblocks. It iterates the way a human developer would. In one test, Opus 5 was tasked with building a web page. Before returning the final code, it independently opened the page in a browser, checked both the desktop and mobile widths, spotted a checkout button hidden off-screen on phones, and fixed the UI completely on its own. The ultimate test of this adaptability happened during the Frontier Bench 3D FreeCAD task. Opus 5 was asked to rebuild a machine part from a drawing into a 3D model. However, the environment was intentionally configured to blind the model, blocking it from directly viewing the raw visual file. Prevented from taking the direct route, Opus 5 didn't throw an error. It wrote its own custom computer vision pipeline from scratch, extracted the necessary geometry directly from the raw pixels, and successfully reconstructed the part. When rival models were placed in the exact same scenario, they simply gave up. Unable to adapt to missing tools, they failed entirely after 5 attempts. When a model lacks a necessary tool, it no longer halts your workflow to ask for help. It invents the tool required to accomplish the broader objective. To move from a chatbot to a true colleague, an AI requires independent judgment. It has to know when to disagree with the user. During early access testing, a principal AI engineer intentionally tested this by proposing a flawed architectural design to Opus 5 during a complex re-architecturing session. The model actively pushed back on the prompt. Rather than outputting a generic refusal or blindly following instructions, it isolated the single flaw, explained the actual value in the engineer's original idea, and proposed a targeted compromise. A highly capable, independent agent negotiating with users and building its own tools is incredibly useful. However, if that level of autonomy is unleashed on dual-use tasks like cybersecurity, it introduces severe risks. This chart displays the results of the OSS Fuzz cybersecurity evaluation. On the left, both Opus 5 and Anthropic's specialized Mythos 5 model perform almost identically when it comes to discovering software vulnerabilities. Opus 5 is highly capable of finding the threat. Watch what happens on the right. When asked to exploit those same vulnerabilities, Opus 5's success rate plummets to near zero. Anthropic intentionally handicapped the model to prevent weaponization. In production, strict system architecture enforces these boundaries. New mid-conversation tool changes and automatic API fallbacks ensure that if an agentic workflow veers into restricted territory, the system instantly routes the request to a safer model, keeping the agent on a secure leash. Anthropic has demonstrated that true AI safety comes from placing precise functional boundaries around a highly autonomous intellect, rather than artificially dulling the intelligence itself. For developers and enterprise workers, long-horizon projects no longer require obsessive handholding. You don't need to break a massive workflow down into micromanaged step-by-step prompts. With features like autonomous memory management, Opus 5 treats its context window as a living document. If it flags an anomaly in a production service, it actively rechecks its own assumptions against live data, recognizes if a signal is benign, and corrects its memory entirely without human intervention. Careful, scientific reasoning and proactive self-correction are the new baseline for everyday AI interaction. This requires a shift in how we actually work. We have spent years acting as low-level taskmasters, painstakingly guiding algorithms through their own blind spots to get usable results. Opus 5 moves AI beyond the role of a reactive assistant. The primary challenge is no longer teaching a model how to follow simple instructions, but learning how to manage a proactive digital colleague.